Hello there, folks. It's Tyson, and instead of being upstairs, we are back downstairs in the basement workshop. So today we're going to look at some special numbers. We are going to check out a bit of music, and we're going to talk cars a little bit. So let's get ready. Let's say hi to little Tyson. Let's hit the lights, and let's get down to business. So we are back in the basement here, and you can see some good stuff in front of me. These are called base 10 blocks. There's a video that we made, the first video actually, about how you can make some of these base 10 blocks. They are just made on the back of an old cereal box actually. So I printed them out, I glued them on, and now we've got something that we can use to actually touch our math and see our math, which is pretty cool because math, it's one thing to think about it, but it's a lot easier if you can touch it, if you can see it, if you can actually kind of play with it a little bit more. So the first thing that I want to talk about is how can we make 100? If we look at these blocks here, we can do that a few different ways. I want you to just think about that for a second. How can you make 100 using base 10 blocks? So we've got this one right here, which is already 100 because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you may know this from counting and using base 10 blocks. You might know it from mental math. But what we have here is called an array. And this is a 10 by 10 array because we have 10 going this way. We also have 10 going that way. So we can say it's 10 by 10. 10 by 10. Cool. Now, I'm sure you've probably noticed something similar between this block of 100 and these rods here. Do you know how many squares are in each of these rods? Guess what? It's 10. So that means that if we use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this also gives us what we would call an array of 10 by 10. And you can see that here, right? You can see this one is 10 tall, 10 wide, and it looks the same as this. And actually, you know, we can line them up right on one over top of the other, or we can see that they're the same because they actually take up the same amount of space. So no matter how you make it, this is a group of 100, and here we have 10 groups of 10, and I don't have enough of them, but if we really wanted, we could use 100 of these individual singular blocks. So let's write that down. How would we write it? This one, we are going to say one group of 100, because we've got one group there, and we can also write that like this. 1 multiplied by 100. And, of course, that's going to equal 100. Okay, so we've got one group of 100. Now, we talked about this. We've got 10 rods here. Woo! I'm losing my markers. Okay, so we can take the time to make these look a little bit nicer. Whoop, whoop. Okay, and now here we don't have, we have, well, I mean, I guess when we put them all together like this is one group. But remember that these are all actually separate. So we have how many groups? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we've got 10 groups. And how many blocks is in each one of those groups? We counted it before. Let's count it again to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 groups of 10. Now, can we write that in this same way, like a multiplication equation? I think we can. So we've got 10 groups of 10 blocks. And hey, that equals the same. Look, we can look and see that it equals the same, or we can just remember. We can use our mental math. Once we get comfortable with these numbers, 10, 1, 100, it can be pretty easy to remember that mental math. So I see that I'm running out of space here. I'm going to see if I can make a little bit more space for our last one. I'm going to move this all the way out of the way here. Okay, so, I would write this underneath typically, but we got to do what we got to do. So let's count these out. We've got, whoa, they're sticky. So we have 1, and I know this is a little difficult to see on the white background, but we'll get back to that yellow in a minute. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I only have 10 here. So, I can say I have one group of 10. But is that the same as this? Just look. It takes up a different amount of space. It's actually quite a bit smaller. So this one, we don't have a total of 100, but we can still write it as a multiplication equation like that. So let's try it. We've got one group of 10 blocks, and this is probably our easiest multiplication equation to actually figure out by looking and feeling, because we can just look and count easily. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 multiplied by 10 equals 10. Okay, so I'm going to draw a line here, because remember, these are a bit different. Here we only have 10, and here we have 100 and 100. But just wanted to help you get a little more comfortable with that idea of 1 and 10, 100, and we're going to clear that off, and I'm going to tell you a little bit about why I'm telling you this. So, earlier, a little while ago, I'm going to get in here. Earlier, I did a lesson about making the wood cart and spacing out those different vertical bars, right? And we were doing a bit of math, some mental math, and I got really bogged down with trying to figure out how can I divide 91 centimeters by 3? How can I make 3 equal spaces using 91 centimeters? So I think I did a decent job using some mental math trying to figure it out, and I tried to take my time, and that helped us figure it out pretty well in the end, but it was a little confusing. So I hope this way we might be able to clarify and understand a bit better. Let's see what happens. Okay, so here was my issue. I was trying to figure out how to do 91 centimeters divided by 3. And, I was thinking about it, and I was going about, well, I can divide 90 easily, and, things got a little bit messy there. I tried to take my time and work through it, but we got there in the end. Didn't want to leave you hanging, though. I like to try to explain things as well as I can. So, if we want to divide that 91 by 3, I thought after, when I looked, I was like, instead of thinking about 91, maybe I should have thought about 90, because I wonder how we can do that. It's pretty simple when we think about it, and let's check this out. We're going to have group 1, group 2, and group 3. So I'm going to count out 90 of these rods. Oh gosh, sorry, 9 rods, which is going to give us 90. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to take 1 away, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I divide 90 by 3, let's see what that equals. I'm going to just kind of deal these out, almost like playing cards. So this is how I think about math sometimes. We can just divide them, sharing one at a time. La la la. Okay. So, hey, that works out pretty well in the end, right? We've got 1, 2, 3 groups of 3. So what we can see here is we already counted before. We know that we have a total of 90. We have 1, 2, 3 groups. And so what that tells us is that the total number in each group is the answer to this. So let's count by tens. 10, 20, 30. Okay. So there's my answer. You know, it would have kept things nice and simple if we did it like this, but sometimes things go the hard way. So let's check out the way that I was trying to figure it out. I got all over the place. I was talking about 90, 100, and 10 left over. So let's see what we've got. I'm going to start out with 100. And let's see if we can divide that by 3. This is where we got into that thing that I called the repeating decimal. So we have here, how many groups of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 groups of 10. Now let's try dividing those between these 3 groups here. Okay, trying to share it around, keep it nice and even like we did with when we had 90. But now I have 1 group of 10 left over. So we're going to, instead of bringing in the big guns, we're going to bring in the small guns. We're going to trade this. We've got 10 here. We're going to use individual single blocks to sort this out. That's 5, 6, 7, 8, 9, 10. Okay, so I've added 10 here. I'm going to take that 10 away, and now we can divide these up a little bit more easily between these 3 groups. Just doing some morning math. Okay, so, hey, flip that over. So now we see that in each of these groups, we have 1, 2, 3 groups of 10 and 1, 2, 3 ones. So if you're someone who's into long division, what you might say is that 10 divided by 3 is going to equal 10, 20, 30, 1, 2, 3. So we could say that's going to equal 33 and remainder 1. Because we've got this little 1 left over, there's not much that we can do with that. So this is one way to solve that and to write it, and that's correct. That's good. But I'm not satisfied with this 1 left over. Oh boy, we've split in half here. So is there a way that we can divide this 1 between 3 groups? Well, we started out with 100 divided by 3. Let's see if we can divide 1 between 3 groups. That's pretty tough. Or, at least we can say it's not going to be a whole number. It's going to be something smaller than 1. So you might not know this, but if you've learned about fractions, we can write, let me say this, 1 divided by 3 is actually meaning the same thing as this fraction. So when we're going to speak about this, we can call it 1/3. So we have the 1 up there, the 3 down there, and that's where the name comes from. So we have 1/3. Now, honestly, I don't know how to explain this without using a calculator. So if you do 1 divided by 3, the number that you get is actually this number. Remember we said dividing 1 by 3 is going to give us a number that's smaller than 1. So we end up with 0.333, and then we can actually put 3 dots. That's called an ellipses. But what that means is that these 3 numbers just keep repeating. So we've got 0.3333333 all the way till the end of time. So what we can do then is we can imagine that we're actually going to cut up one of these blocks, and I'm going to do my best to cut it evenly into 3 different pieces. So I'm going to trade this single block out for, whoop. Be very careful when you're using scissors. Always keep those fingers far from the blades, as far as you can. So now we actually have here, instead of 1, a single 1, what we have is 1/3, 1/3, and 1/3. So I'm going to add our 1/3 to each spot here. And we have 10, 20, 30, 31, 32, 33, and 1/3. So I'm going to write that right here. 33 and 1/3. And in the end, that means that if we go back to this equation, 100 divided by 3 equals 33 and 1/3. And the cool part about this is no remainders. We actually split this up completely evenly between those 3 groups. So I think that's pretty cool. I'm going to pop over upstairs and give you a little taste of this 33 1/3 and where that actually comes into life. So I'm going to try something new. I've been working on some magic. Are you ready? 1, 2, 3. Okay, I don't know if that magic worked or not, but we are upstairs in the music room zone, and this is a record player that I got a few years ago, and I really love this thing. I got it when I was with my wife. She said, if you don't buy that, I'm going to. And it was at a garage sale. It works wonderfully. It looks pretty cool, and it's actually only cost me $10. Can you believe it? Okay, so the reason we're back up here is because this is a record, or this is an album. This is the cover for it. And this right here is the record. So this is an album called Seasons by a group named Magna Carta. And if you check it out on the record there, you see this actually says 33 1/3. So first, let's get that on there. Okay, and if we look in here, this is 33 1/3, and you see pitch control. So what that means is that when we start this record turning, it's actually rotating like this at 33 1/3 RPMs, or revolutions per minute. And then you can hear the music. So the way that record players work just blows my mind. That's something that you can look into if you want. It's related to, we could say it's related to forces, a little bit to magnets, definitely related to sound, a lesson that we did. So how does a record player needle work? Great question to look into. But we're turning at 33 1/3 right now. And let's check out this switch. Let's see what happens if we turn it to 45. I think we can do this. We'll see. Woo. Whoa! The pitch went up. So it's a higher pitch now.
This is the turning of the year.
Whoa!
The final scene before the curtain falls.
Sounds like a chipmunk or something. He must have gotten in from this wildlife painting. Okay, let's see. I don't know if this will work. Let's see what happens if we turn it up to 78. Whoa! Look how fast that's turning. Okay. This is getting too wild for me. I'm gonna go down to the stop button here. We're gonna cool it and we're gonna head back downstairs. We are safely back downstairs, away from that speeding record that nearly threw us off the world because of its centrifugal force. But now we are here to talk about something else. This thing looks kind of like a clock, but it's not. I'm going to cover that up for just one moment, and we'll talk about that in a second. But we were talking about the record that turns at 33 1/3 RP. Oh gosh, there we go. RPM. So this word means, well, this isn't a word, this is actually what we call an acronym. So it's a few letters that stand for something. So what that means is revolutions. P is for per, and M is minute. Oh, revolutions, pardon me. So if we have a record turning at 33 1/3 RPMs, or 33 1/3 revolutions per minute, what that means is that it is turning one complete full turn each minute. So you might wonder, why am I telling you that? Let's imagine it with this. So if we're keeping our eye on here, and if this is our record, that means that every minute the record is turning, or revolving, whoop, back to that point where it first started. So in 1 minute, it revolves 33 1/3 times. Okay, so I've got a question, thinking about our estimating. If it turns 33 1/3 times each minute, then how much does it turn, or how many minutes does it take to turn 100 times? Let's see. Well, we know that 100 divided by 3 is 33 1/3. So if we think from the back to the front here, that means that it turns 33 1/3 times each minute, And so in 3 minutes, it's going to turn 100 times. Pretty cool, hey? All right, our last thing here, I teased you with it before. I know that there are some folks that I work with who like trucks and cars, so those people might recognize this, but this is what is called a tachometer. And it looks like a clock, like I said, but you'll notice that the numbers are in all different places. Normally with a clock, you have 1 up here, 3 there, 6 at the bottom, and 9 over here. So we've got totally different numbers on this one. And the reason we do is because it's actually counting RPMs, revolutions per minute. And you'll see this in your car, in your truck, in almost anything that's got an engine that you're driving, that you're going to be driving really fast. So what happens is when you hit the gas pedal in that car or that truck, vroom, then the engine starts turning the crank and doing its thing, and this needle is going to go up. So when you press the gas a little bit, it might go up to 1, it might go up to 2, or when you really floor it, and for example, if you're starting from still at a stoplight, when someone that's driving first pushes their foot on the gas, it might go up to 4, it might go up to 5 RPMs, or it might go even higher. But when some people look at this, they think, oh yeah, okay, so when mom puts on the gas, my engine starts turning at 4 revolutions per minute. Well, that's actually pretty slow. The record turns even faster than that. But that's why if you look on your tachometer, it will probably say multiplied by 1,000. So that means that if you're in the car and your tach, or your tachometer, is at 4, your engine is actually turning at 4 times 1,000. Can you do that math? It's a pretty good mental math one. That means that the engine or your crankshaft is turning at 4,000 revolutions per minute. Can you imagine that? That's so fast. So that's all I wanted to show you today. Wanted to clarify that mental math I was trying to do. I hope that worked a little bit better for your mind. It was better for my mind using those base 10 blocks. And we talked a little bit about records, a little bit about music, a little bit about trucks and cars. And I actually made a package about that album, Seasons, from Magna Carta. So if you want to do some work around that, if you want to listen to some music and have some fun learning with that, let me know and I can send that on to you. I made it for grade 6s, but hey, you can try it if you want. Why not give it a go? So that's it for us today. And remember, you can send comments into the bottom under the video if there's something you want to learn about, if you have questions about this video. But for now, let's say goodbye to little Tyson. Let's turn off the lights. And we'll see you next time. Bye-bye.